All right, Drake class, these are our notes tonight. 6.4, sum and difference formulas. We'll derive these in class tomorrow, but for right now, we're just going to show how they're going to be useful. Remember that we do know values on our unit circle. We know all increments of 30, 45, and 60. We know all those increments around the circle. We know them in the first quadrant, the second quadrant, and the third quadrant, all with those reference angles. So that means we also know 150, we know 135, and we know 120, and so forth and so on for those. Notice all the denominators for those are over 2. So what we're going to do is we're going to use these to be able to find other possibilities around for sine and cosine other than just the ones on our unit circle. So first thing we have is our sum and difference of cosine. These formulas you'll find on that yellow sheet I printed out for you guys. And these are your sum and difference formulas. So you can see here with your cosines, notice the kind of the patterns here. Cosines in the front for both of them. Okay, alpha, beta. Where if you're adding two angles, it becomes subtraction, and if you're subtracting them, it becomes addition for sine. Notice both these are sine at the end. So we won't have to memorize those. You'll have your identity sheet, but let's go ahead and see how we're going to use these. So if I want to find the exact value of cosine of 105, yes, I can use my calculator and go to my home screen and say, all right, what is a cosine of 105? Make sure my mode is in degree, and then I hit enter, and I see I get that negative 2588 irrational number. It's not exact, but I can get that in my calculator. Well, to get my exact answer, I can go ahead and use my sum properties of cosine. So notice I want to think how I can use 45, 30, and 60 to get to 105. Well, without too much stretch of our imagination, we can see that cosine is of 60 plus 45 is equivalent to the cosine of 105. So using my sum products, I can do the cosine of 60 plus the cosine of 45. The sign switches, so this is minus for cosine, and then I do sine of 60 cosine, that stays sine of 45. Now, these are on my unit circle, so I can go ahead and substitute those in. The sine of the cosine of 60 degrees is going to be 1/2. The cosine of 45 degrees is square root of 2 over 2 minus the sine of 60 is square root of 3 over 2, and the sine of 45 is the square root of 2 over 2. Multiply them out, top by the top, bottom by the bottom, multiplying fractions, square root of 2 over 4 minus square root of 6 over 4, which will be equal to square root of 2 minus the square root of 6 all over 4. So we can see we can't simplify that anymore. The radicands are not the same, so I can't subtract them. So that's my final answer. Nice thing is with these is we can always check our answer and do our square root of 2 minus square root of 6 get that value, divide that whole thing by 4, and you can see I got the same answer as I did with my calculator. All right, so that's using cosine. There's it kind of worked out with the book and the PowerPoint. So the sum and difference formulas for sines. Notice kind of the similarity and differences here. Notice for sine, the signs are the same, okay? But they alternate. We have sine of x, or sine of alpha, cosine of beta. Cosine of alpha, sine of beta. For the difference, again, sine is the same, but these alternate. So it's sine of alpha, cosine beta. Cosine alpha, sine beta. All right, so let's go ahead and look at an example for this. So for a lot of these, I don't like working with radians because seeing the addition and subtraction for radians, you got to get common denominators for your angles, and I don't always see them as well, so I'm always going to convert things into degrees first. So if I see negative pi over 12, I'm going to convert this into degrees, and I'll see that this is equal to negative 15 degrees. 180 divided by 12. So this is the same thing as the sine of negative 15 degrees. Well, again, I can plug that into my calculator, and I can do the sine of negative 15 degrees, and I get that same decimal. And actually, it ends up being the same as the problem we did before. So let's go ahead and figure out how we can use our formulas to get that solution. So I'm going to use sine. And again, I have my values of 30, 45, and 60. Well, there's a couple different ways I could do it. I could do 45 minus 60 or 60 minus 45. Both will give rise to the same solution. I'm going to go ahead and choose to do sine of 30 minus 45, which is sine of negative 15, and I'm going to use my difference formulas. So sine, I'm going to have sine of 30, cosine of 45, sine. So the same. Then I have cosine of 30 and sine of 45. From there, I'm going to go ahead and plug in what I know for my unit circle. The sine of 30 degrees is going to be 1/2. The cosine of 45 is square root of 2 over 2, minus the cosine of 30 degrees is the square root of 3 over 2, and the sine of 45 is square root of 2 over 2. Multiply these out, we get square root of 2. Oops, that was just over 2. My bad. And then I get square root of 2 over 4 minus square root of 6 over 4, and I get square root of 2 minus square root of 6 over 4. That's where we're going to leave off here with 6.4, sum and difference formulas. We'll do the second part the following class period.